Good morning. Today we are going to add and subtract rational expressions. So we're going to be adding fractions that have polynomials on top and on the bottom. And if you guys remember, back in elementary, you guys learned how to add fractions. We know that in order to add two fractions, we need to have the same denominator. In this case, the lowest common denominator will be 4. So I'm going to multiply the right fraction by 2. I multiply the top by 2, the bottom by 2. So the first fraction is 3 over 4. 1 times 2 is 2. 2 times 2 is 4. Now that they have the same denominators, I can go ahead and add 3 plus 2 is 5. The denominator stays the same. So our answer will be 5/4. We are going to go through the same process to be able to add fractions. So on example 1a, we are adding. In this case, we have the same denominator, so this will be an easy problem. 3 plus 4 will be 7, divided by, and you keep the denominator the same. So 7 over 8x will be your answer. Let's look at example B. On example B, we are continuing to, we have a subtraction, but we continue to have the same denominator if you guys notice. If you have a subtraction, the best thing to do is to change it right away to an addition. So we're going to change this to an addition, and we're just going to make the 6 the opposite. Whatever's on the right hand side will be on the opposite. Now, because they have the same denominator, it's an easy process. We're just going to add 3x minus 6. Remember, they're not like terms, so we're just going to leave it as 3x minus 6 over, keep the denominator the same, x minus 4. Now, ideally, you want to be able to see if you can factor the numerator once again and see what cancels. But for now, for today, we're just going to leave it as this. Ideally, you want to be able to take out 3 from here, and it'll be 3 and then x minus 2. But nothing will cancel, so we're just going to leave it simple as that. Let's look at example number 2. Now, on example number 2, we are adding, but if you guys notice, we don't have the same denominator. So what you want to do, you want to be able to factor the denominators and then see what you need to multiply to make them the same. I can go and factor out this denominator. So it will still be 3 over. Take out the common factor. One number divides 5 and 10. 5. Do they both have an x? No. So I can only take out 5. What do I need to multiply 5 to get 5x? Will be x. What do I need to multiply 5 to get negative 10? Will be negative 2. Then plus. On this denominator, it's just 5 times x. So we can just leave it as this. Now because there's no plus, there's not 5x plus a number, we can think of this as two individual factors. 5 is a factor and x is a factor. The same way that on the left, the 5 is a factor and then the x minus 2 is a factor by itself. I need to have the same denominator. So that's it. On the right hand side, many of you guys are going to try to just place a minus 2 here to make them the same, but you can't. You need to have multiply by the whole factor. So I'm going to multiply the right hand side by x minus 2. And what you do on top, you do on the bottom. And if you guys notice, on the left, we're just going, this is a 5, we have the x minus 2, we just need an x. So multiply by x and multiply by x. X times 3 will be 3x. Let's go and just leave this as 5 times x will be just 5x multiplied by x minus 2. Plus, let's use the distributive property to simplify this. So 2 times x will be 2x. 2 times negative 2 will be negative 2. This is negative 4. Now we have 5x, x minus 2. Now that we have the same denominator, we can go and add the fractions. We can combine like terms. That will give us 5x. And then we have minus 4. Denominator will stay the same. It will be 5x multiplied by x minus 2. Many of you guys are going to be tempted, and sometimes we are tempted to cancel the 5x. Remember, this is a factor on its own. In order to cancel it, you need to have a 5x minus 4 on the denominator. We don't. We just have a 5x. You cannot cancel. So our answer will be 5x minus 4 over 5x times x minus 2. Let's continue with letter B. As we covered before, whenever we have a minus in between, we're going to change it to an addition. This will be the opposite, will be negative 5. This becomes a positive 3. It's like multiplying by negative 1. But we can just think of change it to an addition and then the opposite. Now that we have an addition, we want to be able to make the denominators the same. So we want to be able to factor the denominators. X minus 2 is the number that divides 1 and 2? No. Okay, do they both have an x? No. So we can't do anything with the first denominator, so we're just going to leave as this, 7 over x minus 2. Remember, we change it to a plus. The numerator will stay the same. And we want to be able to factor the second denominator. So you want to think, is there a number that divides 1, 1, and 6? No. Do they both, all of them have an x? No. So we can just go and factor using double parentheses. So the factors of x squared will be x and x. Factors of 6, I need to end up with a 1, so that'll be 3 and 2. With the positive 1, so that'll be positive, that'll be negative. Now, I can make them both the same denominator. If you guys notice, we have the x minus 2 and the x minus 2. So I just need an x plus 3 on the left. We'll multiply the top by x plus 3 and the bottom by x plus 3. And now they'll have the same denominator. Let's go and use the distributive property here on top. So it'll be 7 times x will be 7x. 7 times 3 will be positive 21. Do not multiply the denominators, just leave it as this. X plus 3, x minus 2. Plus negative 5x plus 3. Denominator stays the same. X plus 3, x minus 2. Now that they have the same denominator, we can go ahead and combine them, add them, combine like terms. That'll give me 2x. 21 minus plus 3 is plus 24. Over. Leave the denominators the same. Now, ideally, you want to be able to take out the 2 that's on top and see if anything cancels. But for now, we're just going to leave it like this. As we advance into the chapter, I'm going to ask you guys to go the extra step. Take out the common factor on top and then see if anything else cancels. But for the introduction, we're just going to be leaving it as is. Now, go and try example C and D. See if you guys can work it out by yourselves and then check your answer and see if you did it correctly. Go and pause it. Great. Excuse me. We have an addition. We need to have the same denominator. So we want to be able to factor the denominators so we can see if we can make them the same. The 5 will stay the same. On the first denominator, on the 2x squared plus 7x minus 4, is there a number that divides 2, 7, and 4? No. Do they all have an x? No. So I can just do my double parentheses. Factors of 2x squared are 2x and x. Factors of 4 are 2 and 2, 4 and 1. I need to end up with a 7. One of them has to be negative, the other one has to be positive. So I'm going to place my 4 in here. That'll give me 8 minus 1 gives me 7. I need positive, so I'll be positive and negative. Plus, the 2 will stay the same. I'm going to go and factor the denominator. The x squared minus 2x minus 24. Is there a number that divides 1, 2, and 24? No. Do they all have an x? No. So I can go and do my double parentheses. Factors of x squared will be x and x. Factors of 24, I need to end up with a 2, with a negative 2, so I'll be 3 and 8, 6 and 4. 6 and 4 will be negative, they'll be positive. Now, I want to be able to make my denominators the same. So we have the factor of 2x minus 1 and x plus 4, x minus 6 and x plus 4. So on the left, I'm going to go ahead and add the x minus 6 on the top and on the bottom. On the right, I'm going to need the 2x minus 1. Now I can go ahead and distribute. That gives me 5 times x will give me 5x. 5 times negative 6 is negative 30. The denominator will stay the same, so it'll be x minus 6, 2x minus 1, and x plus 4. Plus, distribute property, 2 times 2x will be 4x. 2 times negative 1 is negative 2. Denominator will stay the same, x minus 6, x plus 4, and 2x minus 1. Now they have the same denominator. Notice that they're not in the same order, but because they're multiplying, the commutative property tells us that's exactly the same. Now that they have the same denominators, we can go ahead and add the numerators. So it gives me 9x. Negative 30 minus 2 is negative 32 over. Do not multiply it out. You can just leave it as the factor form. That's fine. And x plus 4. Ideally, see if you can factor anything out, but in this case it doesn't, and we're just going to leave as is anyways. So see if you guys did you guys do letter D? If not, pause it, work out letter D by yourselves and see, compare your answers. Okay. So first, if I notice a minus in between, so I'm going to change it to an addition and make this the opposite. I want to go and factor the denominator so I can make them the same. So I'm going to start with the x squared plus 6x plus 9. I'm going to write a little smaller so everything will fit in here. So factors of x, let's go and leave the x plus 1 on top. On the bottom will be anything that divides 1, 6, and 9? No. Do they all have an x? No. So I can just, nothing to factor out. I can just do my double parenthesis. I'll be x and x. Factors of 9 will be 3 and 3. And they both have to be positive to end up with a 6. Plus negative 1. Many of you guys should recognize that this is the difference of two squares by now. X is a square, x squared is a square, 9 is a square. So it should be double parenthesis. X minus 3 and x plus 3. Now, I want to be able to make them the same denominator. So, on the left, we have x plus 3 twice. On the right, we have x minus 3 and only one x plus 3. So, on the left, I need the x minus 3. On the right, I need to make them the same, so I need another x plus 3. Let's go and use the distributive property. That'll be x times x will be x squared. X times positive 1, you have to do the whole FOIL. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. On the denominator, we have the x minus 3. And I'm going to rewrite those as x plus 3 squared because there's two of them. On the right hand side, we have plus. Negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. On the denominators, I'm going to do the same thing. X minus 3, x plus 3 squared. Now that they have the same denominators, I can go ahead and combine like terms. I'm going to combine 1 minus 3x minus 1x. So we only have an x squared. That gives me negative 2 minus 1 is negative 3x, and then minus 6. On the denominator, I'm going to have an x minus 3, x plus 3 squared. Now, ideally, you want to be able to see if the numerator can be factored out to see if we can simplify further, just like we did on the last section. But for now, we're just going to leave it like this, and in any case, this does not factor. As we go through the chapter, I'm going to expect you guys to do the extra step.